All right, now that you guys know how this whole rock cycle works, I want to talk to you a little bit about how rocks are weathered and eroded. All right. All right, so weathering and erosion. Weathering is where rocks are actually broken up. So this is the process of the rock breaking up near the surface. So disintegration, of the rock near the surface. So that's the physical means or chemical means of the rock being broken apart. Erosion, on the other hand, is where all of those broken pieces get picked up by something and moved to another place. And that something that picks them up could be ice, wind, or water. So these sound similar, but weathering is where the rock surface gets broken apart, where erosion is where all of those pieces that have been broken apart by weathering get picked up and moved. Sometimes the mechanisms of weathering and erosion can be the same, right? So rocks can be weathered by water. Water can break up the rocks, but then water can also move those broken pieces away. Right, so we're going to break weathering up into two categories, mechanical weathering and chemical weathering. And then there's different types of mechanical weathering and different types of chemical weathering. Right, so again, weathering is where the rock surface gets broken up into smaller and smaller fragments. Mechanical weathering is where that breaking up of the rock is happening by physical means. So the first example of mechanical weathering is frost action. And if any of you have been driving around here, you've probably gone over a frost heave, and those frost heaves exist because of frost action. And this is where you have a little crack in the rock. Water is able to seep into that crack, and then water, when it freezes, it expands. So water seeps into the crack, the water expands as it freezes, and then that expansion of it freezing widens the crack or deepens the crack. And if this happens over time, many cycles of this, you can get some pretty deep cracks, like in this rock here. So alternate freezing and thawing of water in fractures and cracks. Thermal expansion is a little bit different, right? But also temperature based. So when things heat up, they expand. So as a rock surface heats up in the daytime, the surface of the rock is expanding. Right? As that rock surface cools at night, it contracts back down. And that expansion and contraction, because of that temperature change, causes weaknesses in the rock. So you get all this weakness and cracks in the rock. And then eventually those cracks get so significant that the pieces of rock actually break away. Right? This thermal expansion deal is why you have those grates and bridges. You'll be going over a bridge. Is mostly cement, and then you'll go over this grate that looks like teeth coming together, and that's to deal with the expansion and contraction of the bridge as it warms up or cools down. So as it cools down, those joints will become farther apart. As it warms up, those joints will become closer together. Root wedging is exactly what it sounds like. You get a little plant that comes into a rock, and its seed gets dropped into a little crack in the rock. And as that plant grows, the roots get larger and larger, and they grow down into the crack, and they actually pull the crack apart. So the roots are growing into the crack and then pushing that crack apart, so widening and deepening that crack. And this is kind of a very extreme example of root wedging happening. Salt wedging is a little bit weird. Salt gets left behind from evaporated seawater, and then that salt that gets left behind, it collects in these little cracks or divots, and it actually can abrade or kind of rub the rock apart, pry the rock apart in those openings. A couple other kinds of mechanical weathering. Unloading and exfoliation. So if you have been out hiking and you maybe see these big like slabs of rock that seem like they're peeling away from the underlying rock, this is unloading and exfoliation. So the unloading piece of this, you have this rock down here, this yellow rock that has been buried by this overlying green rock. This overlying green rock gets worn away, right? And this being worn away, or this being uplifted, right, allows this rock all of a sudden to become exposed. So this happens relatively quickly. Relatively quickly, this rock on the bottom becomes exposed. It could be because this yellow rock is being pushed up. It could be because this rock on top is all of a sudden worn away. So when this yellow rock comes up, all of a sudden all that pressure that this overlying green rock was exerting on the yellow rock is released. Right? So now this yellow rock doesn't have all that pressure being pushed down on it. So once that pressure gets released, this yellow rock is able to expand. So this drastically reduced pressure causes the expansion of this outer layer of the yellow rock. And that expansion can result in, again, weaknesses of the rock, and you start to get these joints, these sheet joints. And kind of like an onion, this expansion leads to cracks in these like curved sheets. So the rocks start breaking away in curved sheets. So the unloading piece of this is the drastically reduced pressure caused by this yellow rock being uplifted. The exfoliation piece of this is that unloading process leading to these rocks right here breaking off in curved sheets. Abrasion is kind of what it sounds like, right? If you think about someone like being really abrasive, they like rub you the wrong way, right? So abrasion is something rubbing against the rock, like a physical means of rubbing against the rock. So water abrasion, right? Water moves by these river rocks and abrades away, right? Rubs away some of those corners, some of those sharp corners in the rock, and over time, the more and more abrasion, the more mechanical weathering in that form of abrasion that gets placed on these rocks, right, those edges are going to be worn away until you get these really round river rocks. And river rocks are so round and smooth because that water is constantly flowing over them and rubbing away all of those sharp edges. Wind can also do this. It can blow away or blow past a rock, and over time it kind of takes away those little rock pieces that are forming those sharp edges. So in this abrasion case, the wind or the water is the mechanical means of breaking the rock apart, but it's also taking away those pieces. So the wind and water can be both a weathering component and erosion component. All right, so that was weathering by mechanical means, more physical means. So now we'll talk a little bit about chemical weathering. So this is weathering by more chemical means. And these happen by rainwater reacting with mineral grains in the rock to form new minerals or new materials. And the reactions can occur faster when the water is slightly acidic, which I'll talk about in a second. So solution chemical weathering is like this or this. This is where minerals that are in the rock get exposed to water, and then those minerals that are in the rock dissolve directly into the water. So this is a limestone cave. Limestone, again, is that sedimentary rock made of the once living shells of creatures, or the shells of once living creatures. And that limestone gets weathered by rainwater, and that rainwater contains carbonates because it has dissolved CO2, and that turns into carbonic acid. And then that carbonic acid from the rainwater seeps into these cracks and cavities within the limestone and kind of dissolve those minerals away, leaving behind these sometimes really big caves eventually. This is an example of halite, right? So this rock below here has a lot of halite in it. Halite is rock salt. So some of that salt, if it's exposed to water, will dissolve and become a solution, right? So this is minerals dissolving into solution, and it will leave holes in the halite where that solution chemical weathering has happened. Those holes cause weaknesses in the rock, and then some of this overlying soil is able to fall into them. And this is actually how you get the creation of sinkholes. Hydrolysis is similar to solution chemical weathering in that it's this water combining with substances in the rock, but you're not having a solution being formed. These minerals are not coming out of the rock into solution. Right? So in the solution chemical weathering case, minerals are coming out of the rock, going into solution, and then being removed in that way. Hydrolysis, water combines with substances in the rock to form new types of substances, usually clays, which are softer than the original rock types. So in this case, you have feldspar, which is obviously very hard rock. When feldspar reacts with water, it forms kaolinite, which is a clay, right? So this is a softer substance. This last picture is an example of oxidation. Sorry, no, this one's clay. This last picture is an example of oxidation. And this is where you get the rock exposed to oxygen and water, and that can give really iron-rich rocks a rusty color. Right? So if you can imagine leaving out your car in your yard, gets exposed to oxygen and water, that oxygen reacts with the iron, and it can result in rust. And then that rust will disintegrate over time. Right? So this oxidation can lead to disintegration of the rocks, and it's because of this reaction with the rock to oxygen and water. So these are in iron-rich rocks, and you'll get this rust-colored, weathered surface like here. So we can have acid rain. So you get sulfur dioxide being created from burning fossil fuels, that sulfur dioxide, and then nitrous oxides being created by the burning of fossil fuels. That sulfur dioxide, that nitrous oxide gets emitted into the atmosphere. That then reacts with condensation in the atmosphere to create sulfuric acid and nitrous acid. That sulfuric acid and nitric acid will then make up acid rain. Okay, so this is like acids that are also being incorporated with the other precipitation in the water. So acid rain made up of sulfuric acid and nitric acid, right? And this acid rain can accelerate those chemical weathering processes, right? So it can make that chemical weathering happen faster, especially when it is interacting with limestone or marble structures. And there's a problem with soil as well. It can leach minerals from soil, but we'll talk more about that when we do soil. Okay. So sulfur dioxide, nitrous oxides from fossil fuel emissions react with condensation in the atmosphere to form sulfuric acid and nitric acid. That makes up acid rain, and then that acid rain accelerates this chemical weathering process, especially for limestone and marble stuff. All right, so erosion, again, is the movement of those broken up pieces elsewhere. Right, so these are different kinds of erosion, right? So a river carving through a valley, that river can abrade the valley, which is a form of weathering, but then it also moves those pieces away through erosion, right? Waves cutting it back cliffs. So again, the waves are abrading the cliffs, that's weathering. They're breaking it up, but then moving those broken up pieces away would be the erosion piece. Right? Wind blowing topsoil or blowing across a rock. That wind is abrading, weathering the rock, and then moving those pieces away. So both weathering and erosion happening there. And then same with glaciers, the ice rubbing against a structure abrades the structure, and then it also moves those broken up pieces away. And landslide is a more obvious version of this. Right, so these are just some examples of wind erosion. So over time, it can lead to some pretty impressive structures. And same with water erosion, right? So you can get this carving out of these big canyons because of these rivers kind of making abrading and eroding that path. Right? This would be wave erosion. So the waves have been carving away at this shelf here. And then this can be in a cave, so water dripping downwards, or just from intense rainfall over time. Here's some more examples of wave erosion. So again, like cutting back the cliffs, abrading the cliffs, and then moving those particles away. All right, okay, that's it.